Good day. This presentation is made in partial fulfillment of QUT IFN 661 Mobile and Pervasive Systems for the first semester of 2018. I am Darius Belonia, and I am presenting to you my research for the unit, which is Prevention, Detection, and Response for Elder Falls. We'll begin by defining an outline for the presentation. We'll start by giving a brief introduction as well as identifying the stakeholders and defining our problem. Next, we'll discuss about the sensors and devices, the connectivity diagram, the fog computing analysis, security and privacy, then finally, the conclusion. Introduction. As you can see, we have a high number of elder deaths in the US within the ages of 75 and above, mostly at 85 plus. It doesn't really matter if you're man or women. Our stakeholders will be the elder people, the nursing home management, the nurses or caregivers, the relatives of the elder people, and emergency response. Now, for our problem definition, we've seen tons of research for elder falls, which are mainly focusing on prevention. We've also seen tons of research for detection and another tons of research for response. Now, the aim of this study is to combine all of these three. Sensors and devices. To begin with, we'll use a wearable device which is in the form of the Apple Watch, specifically the Series 3. Now, this device has accelerometers, heart rate sensors, gyroscope, and microphones. We will also use RPI camera with fisheye lens. These cameras capture frames for motion detection, do video recording, do image capturing, and they are easily connectable to Raspberry Pis. We'll also use passive infrared sensors, PIR sensor for short, which detects heat signatures and are easily connected to a Raspberry Pi. Connectivity diagram. Here we see the connectivity diagram and how the devices are to be connected to one another and to the stakeholders. The camera and the motion detector sensor is connected to the Raspberry Pis. The Raspberry Pis may be connected to a switch, or they could be directly connected to a router via internet. They could also be connected to a wireless access point, but we have to buy Wi-Fi dongles for that. So we've chosen Ethernet cables since it'll have better bandwidth too. An alarm, which could be any sound emitting device such as a speaker or even just a bell, acts as an actuator, is connected to the Raspberry Pi with the motion sensor. The Apple Watch could connect to the phone via Bluetooth, or it could directly connect to the wireless access point via Wi-Fi. The aggregating device is a computer which will run a software that has a CouchDB database. CouchDB is a NoSQL DB which is designed for distributed computing. We'll use IBM Cloud's Cloudant, which is also a NoSQL DB based on CouchDB. These two replicate seamlessly and could be configured to replicate once in a while. Fog computing analysis. We have restructured our previous connectivity diagram, and the fog devices identified are within the box with blue broken lines, as you can see in the diagram below. Everyone has a smartphone and it can connect to the wireless access point via Wi-Fi. The Raspberry Pi could transmit an emergency information to the aggregator when its camera sensor captured a falling motion. The aggregator could then notify the relevant stakeholders for the fall. The other Raspberry Pi with motion detector could signal an actuator in the form of a sound-emitting device to inform the elder to be careful and mindful in the area. Security and privacy. Privacy is a very relevant issue in every project concerning human subjects, and that is the reason why this study mainly targets nursing homes. It is for them to know that it will only be used for the purposes within prevention, detection, and response. As for the invasiveness of a wearable device, a study by Xie and Zheng argues that devices for detecting a person's action should be non-invasive since it adds an additional requirement for subjects to wear such device. This is one of the reasons why an Apple Watch was chosen. It is due to the fact that more and more people are wearing them, and we could maximize its full potential by using its built-in sensors as if it was nothing. Video surveillance will also be a concern, as if Big Brother is watching. Again, we are limiting the scope of the study to a nursing home, and all surveillance are only to be used for prevention, detection, and response. As for our conclusion, this project proves that combining prevention, detection, and responding to emergencies like an elder person using IoT is possible and not that expensive compared to the benefits it could provide. Everyone is prone to falling, but elders have higher chances as well as having more fatal effects. IoT devices could help the elder to lessen the threat of the act of falling and its effect by aiding them with data in different forms. An elder person will have sound alerts coming from motion detectors warning him or her regarding high chances of falling in slow places, such as stairs or in slippery or smooth floors. When a fall occurs and is captured by video surveillance, the necessary emergency responders like the nurse and ambulances could be immediately notified. A fall could also be confirmed by the elder if he or she is still conscious using the wearable device by a touch of a button. The device would also confirm the fall, which was captured by the radio surveillance. For more questions, please contact me at the following email address displayed on the slide. Thank you.